Okay, so I'm going to go over Unit 4.5 in geometry with you. And I'm using a new application, a new app, an iPad app, as a matter of fact, called Explain Everything. And it allows me to screencast from my iPad. And so that's kind of interesting. So I'm hoping that this little experiment works, and we can use this in the future. Anyway, Unit 4.5 is called Using Congruent Triangles, and it's really just kind of, an add-on to the other two units that we've just done about how to prove triangles are congruent. This unit is looking at it from the point of view of once you have established congruence of triangles, you can go a little bit backwards and indicate corresponding parts of these triangles are congruent with one another as well. All right, so let's start. So you can see from here that we've got a quadrilateral right here, A, B, C, D. There's a diagonal running through the middle, and we are given that AB is parallel to CD and that BC is parallel to DA. And we are asked to prove that the side AB is congruent to the side CD based on that. All right, well, let's see what we can do here. Well, let's take a look at our proof. Oopsie. And let's see, well, I guess I can't stretch it too much because then you won't see what we're doing. But let's say we're looking at this now, and what allows us to say this? Well, we're allowed to say that AB is parallel to CD and BC is parallel to DA because we were given that. So let's just write that is given. And my handwriting's a little bit messy here on this iPad, but hopefully that's legible. All right, now we are told that let's see if I can straighten this out just a little bit. That angle ABD. So what is that angle? That's angle ABD. We're saying the ABD is congruent to CDB. That's CDB. All right, let's draw a little congruence marks here for ourselves. So ABD is this angle, and CDB is that angle. Now, why do you think we're allowed to say that those angles are congruent? Well, if you said because of the alternate interior angles theorem, I'm running out of room, alternate interior angles theorem, you'd be right. And they also say that angle ADB, that's this guy, and angle CBD, that's this guy, are also congruent, and that's the same reason, alternate interior angles theorem. All right, now, the next step 4, they say BD is congruent to BD. Well, that's easy. That's the reflexive property. And then they say, well, therefore, triangle ADB is congruent to CDB. Now, why do you think they say that? Triangle ADB, this triangle, is congruent to CDB. Well, it looks like we're able to establish congruence between two angles and an included side, right? So what postulate says that will indicate a congruent triangle? Well, that is the angle side angle postulate. So we can say that by angle side angle postulate, we could say those triangles are congruent. Also, now they're finally saying, okay, well, then if those triangles are congruent, well, then AB is congruent to CD. And basically what they're saying then is that's that the corresponding parts of congruent triangles are congruent. So corresponding parts And I don't think I can spell all this out, but I also think you can say definition of congruent figures or something like that, because congruent figures, that means the same shape, same size of each of the corresponding parts. So anyway, so that's that proof. And let's see. Let's pick up now with example 2. And here we're doing another proof. And we're told that A, right here, is the midpoint of MT. Right here, there's MT, so A is the midpoint. And it is also the endpoint of SR. So we got A right here in the middle. And, you know, this diagram's got some little gaps here, but overlook those, please. Anyway, so if we look at the proof, then how can we draw this conclusion? Well, because this has been given to us. Oh, yes, and we're proving that this is parallel to this. The MS is parallel to TR. But anyway, so we're back here to the first step. That A is the midpoint of these two segments. It has been given to us, so we just say given, right? And the next assertion that's made is that MA is congruent to TA and SA is congruent to RA. Now, why do you think that's possible? I mean, why do you think that we say that is true? Well, because of the fact that we were told that A was the midpoint, so that's just plain old definition of midpoint. Okay, and then the next step is, well, we say, well, angle MAS is congruent to TAR. So that's this angle is congruent to that angle. Why do you think that assertion can be made? Well, if you said the vertical angles theorem, you would be right. So that's vertical, let me just abbreviate here, angles theorem. And it is very difficult to write with neat handwriting on this particular app. And so then the next step that they take is they say, well, the triangle MAS is congruent to TAR. Now, why is that? Well, remember, just like a minute ago, we just said that MA is congruent to TA, and we said SA, let me put a little two congruence, is congruent to RA. And so what do we have then? Right now, we've got a side, an angle, and a side congruent to a side, an angle, and a side. Well, that looks like it's the side angle side theorem then that we're going to be using to make that assertion. So SAS, congruence theorem. All right, well then from there we say, well, that angle M is congruent to angle T. Now, why do you think we can say that? Well, because we're saying that corresponding parts of congruent triangles are congruent. So this has to do with the corresponding parts of, I'll say, congruent triangles. Trying to abbreviate here, are congruent. And I'm hoping that you have a little bit more room. You can write that in on your notes. And then lastly, you want to say that MS is therefore parallel to TR. Now, what do you remember what theorem tells us that? All right, so the alternate interior angles converse theorem. So in other words, before we were proving that if we had parallel lines that alternate interior angles are congruent, we're going in the converse, we're going the opposite direction now and saying because the angles are congruent, then therefore these sides, MS and TR, are therefore parallel. Okay, and we're going to continue on with one more proof now under example 3. We are told, we're given that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. And we must prove that triangle BCE, that's this little triangle right here, is congruent to DCE. Okay? All right, well, let's see how we can go about doing that. Well, we're given that angle 1 is congruent to angle 2 and 3 congruent to 4. That's our given, and that's been put in. And then the next step was AC is congruent to AC. This long line right here, AC is congruent to AC. Well, that's my new favorite property, which is the reflexive property. And so we put that there. And then they jump and tell us that triangle ABC, let's see, what is that? ABC, that's this guy, ABC, is congruent to ADC, this guy. Now, what do you think that's based on? Well, it looks to me like it's based on, we've got a side right here that's included between two congruent angles. So I've got, these are congruent, and then I got an included side. So what is that? So that's angle, side, angle, congruent postulate, right? So that's angle, side, angle, congruence postulate. Okay, and then they're going to the next step and they're saying that BC, which is this part, is congruent to DC, and again we're using that corresponding parts of congruent triangles, corresponding parts, I don't know, congruent triangles are congruent. And again, now they're using this again, they're saying CE, right, is equal to CE. Well, that looks familiar. That looks like it's reflexive again. And then they're drawing the conclusion then now that this triangle, which is BCE, or BCE, is this one, BCE is congruent to DCE. Now, how are they doing that? Well, they established, right? Let me draw some congruent marks so it's easier to see. We established that BC and that are congruent, and then that's congruent, or to itself basically. And so again, we have a side, an angle, and a side, and again a side, an angle, and a side. And so which congruence postulate is that? Well, that's side, angle, side, congruence postulate. And that's how that proof is done. All right, on the last page of notes, there is a construction where they want you to take this angle right here and construct a new angle, DEF. And the way that you would do that is you would get your compass and you would draw an arc. Let me just see. You would do this length right here from, and of course I've got this labeled differently from the book, but you would take this length, okay, and mark it off with your arc, and then you would draw another straight edge, and then with your compass, with one end here, you would come out and throw an arc out there that would be roughly the equivalent in length to this. And then you're going to come back in, you're going to put your compass over here, and you're going to swing right here and arc right here to see what this length is. And you'll come back over here and do the same thing here, and then you're going to draw a line through that, and then draw another one going down, just like this. So this is like a triangle now. So this is ABC. Of course, the book has this as AC, CB, but anyway, it doesn't matter. And then this one is D, E, F, and let's just fix this, okay? So we'll call this C, and we'll call this B, just so things line up. All right, so what we're doing now is we're going to prove that these sides all equal each other. And, you know, using, or that these triangles are equal. And let's see, what are we doing here? Okay, so we're writing a proof to verify that this construction is valid. We're using the fact that that these sides are all equal to each other because how do we know that? Well, we know that because we use the compass. Of course, this diagram doesn't look very accurate because I'm not using a compass right now, but if you use your compass, you should have two congruent triangles, right? And we're going to say that AB is congruent to DE, AB is congruent to DE, and AB is congruent, whoops, this should be, okay, that should be AC is congruent to DF. I need to fix that. All right, so that's AC is congruent to DF, right? And then it says BC, that's this guy, I'll put 3 in there, is congruent to EF, like that. All right, so that's all given. Well, so then they jump and say, oh, look, well, then we can say that those triangles are congruent. And how do we say that? What's that based on? Well, that's based on, right, side congruence postulate. Okay, and then lastly, we say, well, this angle, CAB, this angle is congruent to this angle, FDE, and it's, again, that has to do with corresponding parts of congruent triangles. Corresponding parts of congruent triangles are congruent. Okay. Hopefully your notes will look better than mine. All right, that's it for today. I think you're ready for homework.